This video will cover moderate questions relating to the topic of integration inverse trigonometric functions. The first three integrals I will explain now are all involved to the arc sine. They are different styles, but look at how to integrate arc sine using substitution. Let u equal tangent x, then du equals secant squared x dx. Equals the constant number 3 moves here, then the integral of secant squared x over square root of 16 minus tangent x squared dx. Change all x into u. 3, the integral of secant squared x dx equals du over square root of 16 minus tangent is u squared. Then use integral of square root of a squared minus u squared du equals arc sine of u over a plus c. In here, a squared is 16. That means a equals 4. So 3 times arc sine of u over a is 4, plus c. 3 arc sine of u was tangent x over 4 plus c. As I already explained when integrating in beginner, there is a variable before the square root, but the important point is where the variable is inside the square root. Like question 1, just integrate. When u equal tangent x, we can see du is here. But this integral is a little more difficult. Let u is square root of x. In here, I will square on each side. U squared equals x. Now you see 2 minus x is u squared, so 2 minus u squared. And when we do the differentiation to find dx, we don't do it here, we do it here. Then derive on each side, 2u du equals dx. But for those curious, I will show you why I did that. When u equals square root of x, we can rewrite as u equals x to the power of 1 over 2. Then derive on each side, du equals 1 over 2 x to the power of minus 1 over 2 dx. We can rewrite as du equals 1 over 2 square root of x dx. There is only dx, then times 2 square root of x on each side, then 2 square root of x du equals dx. Then square root of x is u, then we can rewrite as 2u du equals dx. We have the same result. How is it? Much more complicated, right? Now let's change all x into u. The integral of 1 over square root of x is u, square root of 2 minus x is u squared, then dx is 2u du equals integral of u is cancelled, 2 over square root of 2 minus u squared du. Use the formula, the integral of 1 over square root of a squared minus u squared du equals arc sine u over a plus c. In here, a squared is 2, That means a equals square root of 2 equals 2 times arc sine of u over a. A is square root of 2 plus c equals 2 arc sine of u was square root of x over square root of 2 plus c, and then final answer is 2 arc sine of square root of x over 2 plus c. Question 3. Rewrite as two fractions the integral of x over square root of 9 minus x squared dx plus the integral of 4 over square root of 9 minus x squared dx. For the first integral, use substitution, and the second integral involves arc sine. Let u equal 9 minus x squared, then du equals minus 2x dx. There is only x dx, then divide by minus 2 on each side. Then du over minus 2 equals, minus 2 is cancelled, x dx. So integral of x dx is du over minus 2, then 1 over square root of 9 minus x squared is u. I used u while doing u substitution now, and I don't need to use another variable. So I will just use x. The integral of 1 over square root of a squared minus x squared dx equals arc sine of x over a plus c. Now we can rewrite as 4 the integral of 1 over square root of 9 is 3 squared minus x squared dx. 1 over minus 2, the integral of 1 over square root of u in the power form, u to the power of minus 1 over 2 du. In here, a squared is 3 squared. That means a equals 3 plus 4, then arc sine x over a is 3 plus c equals minus 1 over 2. The integral of u to the power of minus 1 over 2 is, use the power rule for antiderivative, u to the power of minus 1 over 2 plus 1, which is 1 over 2 over 1 over 2 plus 4 arc sine of x over 3 plus c equals, this one is cancelled, then minus u to the power of 1 over 2 is the square root of u plus 4 arc sine of x over 3 plus c, then finally minus the square root of u was 9 minus x squared plus 4 arc sine of x over 3 plus c. We have 3 integrals involved with arc sine. Now let's do the integrals involved with arc tangent. We can write the denominator as the sum of two squares. Do you remember completing the square? X squared plus bx plus the last term is the coefficient of the middle term, b divided by 2, then squared equals x plus b over 2 squared. So x squared minus 6x plus 13 equals x squared minus 6x, then minus 6 over 2 squared equals minus 3 squared equals 9, then plus 9 minus 9 to make 0, and then keep the last one, equals, this one makes x minus 3 squared, then plus 4. Now we can rewrite as the integral of 1 over, this part is x minus 3 squared plus 4 dx. Let u equal x minus 3, derive on each side, du equals dx. Change all x into u, the integral of 1 over x minus 3 squared is u squared plus 4 dx is du. Use the formula, the integral of 1 over a squared plus u squared du equals 1 over a arctangent u over a plus c. In here, a squared equals 4, that means a equals 2. Then 1 over a is 2, arctangent u over a, u over 2 plus c, then final answer is 1 over 2, arctangent u was x minus 3 over 2 plus c. Question 5, we can rewrite as the integral of cosine of x over 5 plus sine x squared dx. Let u equal sine of x, then derive on each side, du equals cosine of x dx. Change all x with u, the integral of cosine of x dx is du over 5 plus sine x squared is u squared. Use the integral of 1 over a squared plus u squared du equals 1 over a arctangent u over a plus c. In here, a squared is 5. That means a equals square root of 5. Then 1 over a, 1 over square root of 5, arctangent u over a is square root of 5 plus c equals 1 over square root of 5, arctangent of u was sine of x over square root of 5 plus c. Question 6, we can rewrite as the integral of e to the power of 4x over 4 plus e to the power of 4x then squared dx. Use u substitution. Let u equal e to the power of 4x. Derive on each side. Du equals e to the power of 4x times, use the chain rule, 4x prime, then dx. Then du equals e to the power of 4x times 4 dx. There is only e to the power of 4x dx. Then divide by 4 on each side. Du over 4 equals 4 is cancelled, e to the power of 4x dx. Change all x into u, the integral of e to the power of 4x plus dx is du over 4 times 1 over 4 plus e to the power of 4x squared, which is u squared, equals 1 over 4, the integral of 1 over 4 plus u squared du. Then use the formula, the integral of 1 over a squared plus u squared du equals 1 over a arctangent u over a plus c. Now a squared is 4. That means a equals 2. 1 over 4 times 1 over a is 1 over a is 2. Arctangent u over a is 2 plus c equals 1 over 8. Arctangent of u was e to the power of 4x over 2 plus c. Question 7. Rewrite as two fractions the integral of x over x squared plus 1 dx plus integral of 4 over x squared plus 1 dx. For the first integral, use u substitution, and the second integral involves arctangent. Let u equal x squared plus 1, derive on each side, du equals 2x dx. There is only x dx, then divide by 2 on each side, du over 2 equals, cancelled, x dx. Then change all x into u, the integral of x dx is du over 2, 1 over x squared plus 1 is u. The second one, use the formula, the integral of 1 over 1 plus x squared dx equals arctangent x plus c. So plus 4, then arctangent x plus c. 1 over 2, the integral of 1 over u is ln absolute value of u plus, keep the second one, 4 arctangent of x plus c equals 1 over 2 ln absolute value of u was x squared plus 1 plus 4 arctangent of x plus c. In here, x squared plus 1 is always greater than 0. We don't need the absolute value sign. We can rewrite as 1 over 2 ln bracket x squared plus 1 plus 4 arctangent of x plus c. Question 8. I will use the formula, the integral of 1 over a squared plus u squared du equals 1 over a arctangent of u over a plus c. Now let's see how this integral involves arctangent using u substitution. Let u equal square root of x. We can differentiate both sides right here, but let's use the easier way. Square on each side, u squared equals x, then derive on each side, 2u du equals dx. Now change all x into u equals 2 moves here, integral of 1 over square root of x is u, open the bracket, 9 plus x is u squared, then dx is 2u du equals u is cancelled, then 2 times 2 is 4. The integral of 1 over 9 plus u squared, then du. In here, a squared is 9. That means a equals 3. So 4 times 1 over a, 1 over a is 3. Arctangent of u over a is 3 plus c. The final answer is 4 over 3. Arctangent of u was the square root of x over 3 plus c. The question 8, we just find the indefinite integral. And the question 9, we need to evaluate is a definite integral. Compare how they are different. Use u substitution. Let u equal square root of x. Then square on each side. U squared equals x. Then derive on each side. 2u du equals dx. Evaluating the definite integral using substitution is that when a variable is changed, the limits of integration for x is also changed to the integration limits for u. Where x equals 3, from here, u of 3 equals the square root of 3. So the new upper limit is square root of 3. When x equals 1, then u of 1 equals the square root of 1, which is 1. So lower limit is 1 now. Change all x with u. The integral of the upper limit is square root of 3 now. The lower limit is 1. Then dx is 2u du over square root of x is u. Open the bracket, 1 plus x is u squared equals u is cancelled, 2 moves here, the integral of from 1 to square root of 3, 1 over 1 plus u squared du. Now use the formula, the integral of 1 over 1 plus x squared dx equals arctangent of x plus c equals 2 arctangent of u. The lower limit is 1. The upper limit is square root of 3. We do not return to the variable x after integrating. We just evaluate the expression in u using the changed limit of integration. Equals 2 times arctangent of square root of 3 minus arctangent of 1. When theta is pi over 3, the ratio of the triangle is 2 square root of 3 and 1. In here, tangent pi over 3 is square root of 3. That means arctangent of square root of 3 equals pi over 3. And when theta is pi over 4, the ratio of the triangle is 1, 1 and square root of 2. Then tangent pi over 4 equals 1. That means arctangent of 1 equals pi over 4. Then back to the original. 2 times arctangent of square root of 3 is pi over 3 minus arctangent of 1 is pi over 4 equals 2 times, make the same denominator, which is 12. The first one is 4 pi, the second one is 3 pi. Equals 2 times pi over 12, then 2 times 1, 2 times 6. The final answer is pi over 6. This is the last one. We can rewrite as the integral of The upper limit is ln 2. The lower limit is ln square root of 2 e to the power of minus x over square root of 1 minus e to the power of minus x squared, then dx. Use u substitution. Let u equal e to the power of minus x, then derive on each side. Du equals e to the power of minus x times, use the chain rule, minus x prime times dx. Then du equals e to the power of minus x, this one is minus 1, then dx. There is only e to the power of x dx, then divide by minus 1 on each side, minus du equals e to the power of minus x dx. Now change the limit. From here, when x equals ln 2, then u of ln 2 equals e to the power of minus ln 2. Then we can rewrite as 2 to the power of minus ln e. This is 1. Then e to the power of minus 1, which is 1 over 2. When x equals ln square root of 2, that means u of ln square root of 2 equals e to the power of minus ln square root of 2. Then we can rewrite as square root of 2 minus ln e equals square root of 2. This part is 1, which is minus 1. The final answer is 1 over square root of 2. Now change all x into u. The integral of the upper limit is 1 over 2 now. The lower limit is 1 over square root of 2. Then e to the power of x dx is minus du over square root of 1 minus e to the power of x du, then squared. Instead of getting rid of the negative sign, we will reorder the limit. So we can rewrite as 1 over 2 is here, 1 over square root of 2 is here. Then 1 over square root of 1 minus u squared, then du. Now use the basic formula. Arc sine of u from 1 over 2 to 1 over square root of 2. Then evaluate the expression. Arc sine of 1 over square root of 2 minus arc sine of 1 over 2. When theta is pi over 4, the ratio of the triangle is 1, 1, and square root of 2. Then sine pi over 4 equals 1 over square root of 2. That means arc sine of 1 over square root of 2 equals pi over 4. When theta is pi over 6, the ratio of the triangle is 1 square root of 3 and 2. Then sine pi over 6 equals 1 over 2. That means arc sine of 1 over 2 equals pi over 6. Then back to the original. The first one is pi over 4 minus the second one is pi over 6 equals, make the same denominator, which is 12. The numerator is 3 pi and 2 pi. And the final answer is pi over 12. I hope this video has been helpful. If you have any questions, leave them in a comment below. Thank you for watching. Please like and subscribe for more.